All right, everyone, what's up? 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 Okay. Oops. Okay, cool. I guess it's time to get started. Today I'm going to be attempting to solve Avenir Code Day 15 in Prolog. And yesterday was the challenge. First part was pretty straightforward for anyone else who's solved it or seen a solution. But then, part two really it broke me. But I think today, hopefully, I'm feeling like today is going to be a little bit easier. So I'm looking at the problem. I've kind of read through a little bit, but I haven't started coding anything up yet. So the basic idea is you have some kind of grid, and each pound sign is a wall. Each 0 or O is a box, and an @ sign is the guard or whatever, or whoever's moving around. What does it say? A lanternfish guard. Robot. Okay, the robot, sure, is moving around. And it can move in any of the 4 directions, which are represented by these arrows, and then it pushes all the boxes in front of it. If it moves left, then this box gets moved left, and if there's a box here, that gets moved left too, and so on. But nothing can move into the wall. So if you had 3 boxes here, then I guess moving left would not be possible, right? Because you'd shove all those boxes into the wall. So that move just kind of no ops at that point. So I think this should be pretty easy to solve in Prolog, because we'll just implement this as like a recursive rule. We'll say we'll have a rule that this board, the board, input board or grid, I think I'll call it a board. Let's say the input board plus this move is this output board. That'll be our relation. Input board and this move gives you this output board. So we'll define that, and then that can recursively say, well, if I moved the person into a box, then we've also got to recursively move the box, that direction. And then if that box moved into another box, we'll recursively move that box into the other direction, in that same direction, and so on, until something either doesn't run into any more boxes to hit, or it hits a wall, which means it moves impossible. And then we can actually make use of something cool in Prolog for once, and not just have it fight us. And we'll be able, I think we could backtrack at that point until, I guess we'll just say this move failed, and then have that kind of percolate back up until the entire move fails, and at which point we'll just treat it as a no-op. So I think that should be pretty straightforward. And dealing with the list of moves should also be super easy. So in Prolog, you have a couple options for reading out strings. You can have them read as like a normal string, or you can actually treat them as a list of characters, or character codes, I guess there's another option. But what we'll do here, I think, is we'll just read this out as a list of characters, and then we'll just kind of iterate over that list till we run out of stuff in the list. So, and we'll just literally use those characters to signify the different types of moves. So that should be, or maybe we'll like use an actual word like left or right. I guess it doesn't matter. We'll think about that. But that should be pretty straightforward. I think, the other part of this is parsing it, which, almost every single problem in Avenir Code is like a grid like this. So I've written the parsing code like 50 times, getting kind of old. More grid manipulation stuff, right? So parsing it shouldn't be too tricky. I think the big open question for me, I guess there's one more part of this problem, and then that's once you're done moving the board, then you just got to count the positions of the boxes, and I guess the box shown has a distance of 1, blah, blah, what box from the top edge, and 4 from the left. What box are we talking about? Anyways, this box. Yeah, okay. So you just got to look through all the boxes, figure out what their position is, and then you're supposed to multiply it by 100. The GPS coordinate of a box is 100 times its distance from the top edge of the map plus its distance from the left edge of the map. Right. We can actually start writing some of this stuff down, huh? let's see. 100 times its distance from the top edge is y, plus its distance to the left edge of the map. So it'd be something like this. We'd say, but we're not going to need that for now. And I got to bring in the CLFPD library to use this stuff. So okay, so that's a rule right there. That's nice. We'll come back to that, though. We don't need to worry about that stuff right now. I think we could do that at the end. Yeah, I guess actually it doesn't matter what order we approach this in. We could, even with the board, before we apply any moves to it, we could start summing up the GPS coordinates. But seeing how there's no example for that, I think we'll do that at the end. So I think we should start with trying to get one of these examples working. So I think the big open question for me is there's no real special way, I think, to do this kind of stuff. You know, it's pretty straightforward. I think the open question for me is, how do we want to represent the board? What kind of data structure do we want to use? If I were doing most of the time I write Clojure, I don't write Prolog. I am pretty new to Prolog. I've only been writing it really since this year's Advent Code. You know, I've written like a little bit of logic stuff, like core logic and Clojure in the past, so it's like not totally unfamiliar to me. But I'm not like an expert, you know, so take everything I say with a grain of salt. If I was doing this in Clojure, I think I'd probably use a java.util bit set to represent the packages and the walls, and have each bit. So it's like this. Every position has a wall, or it doesn't, right? So that's a 1 or a 0, right? That's a bit. So you can use a bit set and say, this bit set represents all the possible positions, and if it's 1, there's a wall here, and if it's 0, there's no wall. And then we can have another bit set for the packages. If there's a 1 here, there's a package. If there's 0, there's no package, right? And then we'll just keep track of the player position separately. So that, I think that would be probably the quickest, most efficient way to do it. Flipping bits and stuff is pretty quick. And we could even copy the entire bit set, so we can still have it be functional and make a new copy every time. I think a Java util bit set is mutable by default. I think there might actually be like a Clojure version of bit set that wraps it and is immutable. I don't remember. So that's one option. I think a simple vector of vectors, Clojure vectors, like immutable vectors, would still be plenty performant here. So the thing is, like some of these other grid problems in Prolog, you know, my first thought was I'll just make a list of lists, you know, because everything in Prolog is like a list, right? That's like the go-to data structure. So I thought I'd do a list of lists, but then that ends up being super duper slow. You know, it's totally fine when you got a list of lists this size, you know, what do you got, maybe like 10 lists of 10 or something. But let's look at our actual input. Yeah, that's a lot. So if we wanted to move like a package like right here, okay, so worst case, you want to move like a package down here. It has to iterate through all these lists, and then it has to iterate through all the elements in the list, and then, you know, make a whole new list all the way backwards, and then make a whole new list all the way back up, you know. So it's like super duper, it's just like a lot to do any kind of manipulation with these. And then if we're doing like, I don't know, like thousands of these things, it's going to add up, you know. Instead of having like a relatively quick solution, I'll have like kind of a slow one. So I don't think list of lists is a good option here. It would be easy to print stuff, you know, if I did list of lists, which is nice. When working on this, it's definitely nice to be able to kind of see what the heck's going on and if my code's working right or not. But I think we can still print stuff without too much drama if we use a different data structure. So we could use some kind of tree where the key is like the coordinate pair, like X, Y, or something like that. And the value is just, or I guess we could use separate trees for walls versus packages. Definitely an option. And if that has some kind of like login performance or something, then that would be totally sufficient for this problem. But I think like a list of or just one giant bit vector, a bit set or whatever you want to call it, bit array. I don't think it's called bit array. I think it's called bit vector in C++ and like bit set in Java. There's no bit set in Prolog as far as I know, but it does have numbers that can kind of be as big as you want, and there are bit arithmetic operations on them. So I think we could try to do that in Prolog. Will it work? I don't know, but we'll try and see. So I'm going to do a little bit of exploratory coding and even see if I could make this work. So I guess the options here are we could have one for each row. We can have one bit set, okay? Or we can have one gigantic one, and we'll just figure out the offset will be, I don't know, like x plus y times width or something, right? Or is it the other way? X, yeah, we'll do x, and then for the first row, yeah, y times, let's see. Time to start coding it up and see, right? So we'll call it absolute position. So we need to know the height and the width, or maybe just the width, right? Yeah, so I'm going to use like a pair for x and y, I think, today, as opposed to like a list of x and y. So it's x plus y times width. Yeah, that sounds right to me. And then I'll show you what the heck's going on here. Oops. Okay. Okay, so we said something like, so for like a 10 by 10 board, if we have a, let's say 0, 0 should be 0, okay, and then 1, 0, yeah, 1, okay, and then so like 1, 1 should be like 11 or something, right? Okay, and so this should give us like all the numbers. So we can say like p and 0 to 100. No, sorry. X and 0 to 10. Y and 0 to 10. Yeah, and then yep, so I can have it, well, I guess it's, yeah, okay, so it's I'm asking it give me real values. I'm saying we got an x and a y in these ranges, give me real values of x and y, and then solve for absolute position p given x and y, and then I'm having it, spit out, it's kind of generating solutions here, but it's doing y first, right? So y is going up, and then maybe, yeah, okay, so I mean eventually that would spit out everything, so I think that will work for what we want. Apparently there is a get bit function in Prolog to get the value at the nth bit of a number, but not a set bit. So we'll just write set bit ourselves, but I don't think that should be too hard. So I think what we'll want to do, our board will be represented by a number, and we'll say, does it have anything? We'll say like so we'll write a relation like this. I guess we'll use n for board. Okay, so absolute position. I guess we got to know width, so we'll pass that around. Width board. And we'll say bit. Get bit. I swear I looked this up earlier. There's definitely some sort of get bit. Don't play with me thing. It's always alarming when like the autocomplete says it doesn't exist. Don't play with me. Okay, that's concerning. So let's see what happens. Okay, so let's say we have 0, so the value at everything should be like 0, right? Or width 10, 0. And wait a minute. procedure equals what in the heck? Okay. Position. Blah blah blah. What? Oops, okay, well that's not right anyway. That's what we meant. Get bit. Wait a minute. Get bit. Okay. Let's look at the documentation together. Get bit value. Why is this? So this has a 2 arity, right? But you would think you would need to get like have a 3 arity for the value and then the nth bit and then the out value. So maybe this isn't what I want at all. Value is the bit value of the in expression ith bit. What's an arithmetic function? Okay. So I guess we gotta do something like this. Maybe that'll do it. Okay, it's saying there's no procedure # equals to, which is what this is right here, right? You know, it's just this like syntactic sugar to call that. And I'm like, what am I doing wrong? Maybe it's not listening to me when I said use. Okay. Let's try to use just like the built-in lower level math here. See if that fixes. What the heck are you talking about? Value position, huh? Okay, so now we've already managed to get ourselves in like a weird broken state. And I don't know why it gets into this state, but the only way I could figure out to consistently fix it is just to like restart everything. So give me 2 seconds. Okay. Where the heck were we? Where did my stuff go? There we go. Okay, so what were we saying? So like value at position. Oh wait, this should have been. Yeah, at position. So we got a board of width 10, and the board is like 0. And yeah, okay, get bits on a CLFPD, CLPFD function, so we gotta do it like that. Yeah, so V will be either 0 or 1. So now, I guess the only other thing you need to do is like set bit and then maybe set value at position. Bit num and okay, so this will be a relation such that n1 is what happens when you set the bit of n0 at index 2v. Okay, so I think we gotta take 1 and bit shift it index amount of times, right? And then, okay, v should be either 0 or 1. And I think that should go without saying, but let's just put it there to be safe, you know. When you shift v that many times, no, okay. Now if it's 1, then we could just do like an XOR, right? Now if it's 0, if we want to unset it, then I guess, okay, let's think about this. Let's just do just the 1 for right now. So let's do v is 1. Okay, we'll cut so it doesn't try to backtrack there. Then we'll say we'll shift v over by index, and we'll say what am I gonna call this? Mask, bit mask. And n1 is, what is it called? How do you do bit and? I think it's something insane. It's like a literally insane person syntax. I think that's how you do it in Prolog. So it's like N0. Mm-hmm. Right, okay. And we'll do the v equals 0 in a second. So how's this look? How's this look? V1, blah, 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 yeah. Okay. So if we set the bit at 0, we should still have, the value should be like 1, right? What are you talking about? I messed something up somewhere. Oh, there we go. Yeah, and if we set the bit at 2, it should be 2. No, what the heck are you talking about? 2-bit mask. Oh, we said XOR, didn't we? We don't want AND, we want XOR. XOR, how the heck do I XOR? I think it's XOR. Okay. Bit mask. Oh, this is why it's not working. I got my arguments in the wrong order. So 2, okay. Yeah, okay, so if we set the bit at, well, I guess this is, I guess, going from the right. Okay, so we set the bit to the right. The second bit from the right is 2, and then third bit from the right, or 2 with the 0 index would be 4. Okay, I think that makes sense. Now let's see if we could like unset that bit. We got to get this stuff working for unsetting. So it doesn't work yet, but we could say, now how do you unset a bit? I guess you, so if it's 1, we want to flip it to 0. I think we have to, wait, I guess you could bit AND with everything else set to 1 except for that 1 bit, right? But is there some easier way to do it? I think we're tripping, you know, because like, hold on a second here. I don't think XOR actually does what we want, right? Okay, XOR is not the right way to do it because that assumes you already know what the value is, right? Oh, no idea, no idea. Okay. Okay, so so if it's already set to what we want to set it to, we don't need to do anything. So otherwise we can XOR it. Yeah. Right? XOR it with 0. Okay, I'm not sure. Okay, for 1 we could definitely XOR it, right? So okay, so that looks good. But now we want to set it to 0, and I think we got to do something different in that case. Yeah, because it's still 2, and it should have went back to 1 or whatever. Okay. So we got to add like one more branch in here. Otherwise, if v is 0, then we just gotta bit shift 1 over that many times and use that as the bit mask. Yeah, okay. Right. And then in either case, then we apply the bit mask, right? Yeah, that looks pretty good to me. Okay. Yeah, okay, so n is 0, and then we flip the bit at index 1, and that gives us 2, and then we flip it back to 0, and now we're back to 0. So I think that's our set bit right there. So now let's work on set value at position. Position with we'll call it board. And we'll say and this, we don't even need to destructure this, honestly. We could just say P. And for that matter, we don't need to destructure either up here. But I'm going to rename this to absolute position to be clearer. Okay, so we're going to get the absolute position, and then we're going to set bit board 0, absolute position, value board 1. Okay, cool. So now I think that we got everything we need to actually kind of start working on this. So now we just got to read a data structure in, and so we're just going to use some big gigantic numbers to represent everything again. We're going to represent all the walls as just one giant bit set, or in this case, just a really big integer, but it's really the same thing, right? So, and then we're going to represent the packages as another one, and then we'll just keep the position separately. So we'll have kind of like 3 things we'll pass around. And then each state manipulation will just be moving the packages and moving the player, and the walls don't move, right? So it'll look something like this. Move will be, let's say walls. Or not player, it's called, what's it called? Robot. So that's what relation we need to write next, okay? But before we get that, I think we actually want to write some input or parse a little bit of input so we can actually do something and kind of have something to test in a REPL. So I'm just going to copy like the very easy example right here. And let's see, how do we want to do this? I'll just make this a big string like this. I think that's okay for right now. So I could do, okay, and so actually by default in SWI Prolog, it'll parse double quoted things as a string, but we can actually take advantage of other ways to have it parse it by setting the flag for double quotes. So in this case, I'm going to parse double quotes as list of characters, right? Yeah, so it's actually already breaking that out into a list for me. So I'll do it like this. Parse input. We need to parse this into walls and packages and player position. So we want to write this relation now, and so we'll pass in the input string, and then it should spit out walls, packages, player position, right? Or sorry, robot position. So we'll want to parse these one character at a time and kind of keep track of what position we're at, X and Y. So I think we'll want to have this kind of hand off to a 5 arity that starts at 0, 0, like this. That'll be X, Y, but we are parsing, yeah, okay, never mind. Okay, so we're gonna write this recursively. So whenever you write something recursively, you gotta always good to start with the base case. So what do we do when there's no more input? We're done, right? So it doesn't matter what X and Y are. And walls and packages and robot position are done. Actually, to make this work, we're actually gonna need to have kind of 2 versions of all of these things. We're gonna have these relations are gonna have like kind of the before and after, right? So we'll do it like this. This is a lot of arguments, and I don't love this many positional arguments in anything. You know, it's kind of hard to look at and easy to mess up. But I think this will be fine for now. So basically what's going on is we'll have kind of like the accumulator version of walls and packages and robot position, and then the actual kind of meat and potatoes of this relation. We'll take that and then add like another bit to it for each iteration, each time it recurses. So the initial values for all those are going to be walls, packages, and robot position will be 0, 0, and then 0, 0 respectively, right? So here's how we'll do input. So we're going to destructure the input and get the first character, and then we'll say if character is £, then we need to add a wall. Okay, so okay, hold on a second. We could write this rule in a better way. We can have the destructuring itself do the pattern matching. So we could say if this is a £, XY, we'll come back to this version in a second, then walls needs to be different, but packages and robots are the same on either side of this equation, right? So we just need to say walls 0 is actually, walls 1 is no, we're not making a list. Never mind. That's not how we're gonna do it. 1, and we'll say set value at position will be width. Oh my god, we gotta pass width around. Jeez, this is just too much, too many arguments, huh? I guess we'll make that the first argument. Let's just see if we get this working, and then we'll go kind of despair about how our code looks after that works. Okay, so set value at position width, and what else do we say? Board 0, but in this case, it's not really a board. Well, I guess, okay, wall 0, 0, and then we're gonna set it to position is XY. I'm gonna set it to 1, and then we just gotta recurse, right? So oh, so we gotta increment XY. You know what? Keeping track of XY like this is dumb. We can just keep track of the absolute position and then not have to do any math, because otherwise we got to figure out when, oh, do we increment Y every time? Oh no, well, Y is equal to width now. We got to set it back to 0 and increment X instead. That's like a lot of work to do every time, right? So why don't we take width back out of this and we'll just keep track of absolute position, right? Then it doesn't matter. Okay. XY, so nope. Okay. Then we'll input more. Wait a minute. I don't know if we need. Let me think about those walls. More wall. Do we need both sides? Do we need both versions of everything? Walls, more wall, because it has to add them all together. Yeah, I guess we do, because it has to have like the input and then it has to add something to it and then spit it back out. So yeah, okay. Okay, so I think that would be how we'd like deal with a wall cell. So we're taking wall 0 and then we're flipping a bit, and then that's giving us walls 1, and then, you know, so instead of doing wall 0 in, walls out, now we're doing a walls 1 in and then walls out. So we're kind of changing this part just like that. And we don't need width anymore, right? Set value at. But now we don't need absolute. We actually, I don't think, I'm not sure we even need that anymore because we have absolute position, right? So we'll have so I think that should take care of the walls. And then we need 3 more rules for 2 more rules for the player, no, packages, player, and then nothing. So the nothing rule should be pretty easy because we don't need to change anything, right? Don't need to set any bits. We just need to kind of set the next position. Okay. Then we'll do a package. If it's this character, blah, blah, blah. Walls are the same, but packages will change, right? So. This is, writing all this stuff 4 times is like making me itchy, but in the interest of time, I'm gonna say this is good enough for right now. And I think the only thing that's like a little bit different here is the player position. Well, it'd be nice to have XY for the player position instead of like an absolute position, but I guess we could just run absolute position in reverse actually and get that later. So since there's only one robot position, I guess right, okay. So we'll just ignore, if there's already input for it, and there shouldn't be, then, and we can actually unify that right there. Absolute position, robot position is the current absolute position, right? Yeah, okay. So, yep, I think that should do it. Will it do it? Let's see. See how well this works. Okay, so input and then parse input. Well, we don't need to be printing this every time. Okay. Well, it already doesn't work, huh? So, what did I do wrong? Packages, robot position. Right. So I think at this point, well, I could either use trace and step through it, or I could step through it, or I can disable some of the rules and then see why things aren't working. There's not any other characters, right? I got all 4 characters, right? So I'm starting to wonder if it would have been better just to write this as one big rule and then just have kind of like a switch or like a case statement equivalent for which character I'm dealing with, or some other way to kind of make this less hairy, because now, you know, it's got all this code to debug, right? So okay, let's think about this. Yeah, let's just try stepping through it with trace. Set bit, and we'll see where it fails. Fail. Set bit. It's failing in set bit. Why would it fail? That package is 0. Oh. Okay. Right. Let's turn off tracing. Okay, so that still doesn't work. I think a better way to do this would just be to parse these one at a time. Maybe not as efficient or whatever, but it'd be a lot easier to debug. So let's kind of rework these, and then they'll be a lot simpler too. So yeah, I'll just get rid of all this stuff. And we'll work on this relation now. So start with the base case. Nothing left, then walls in and walls out will just unify with self. We don't care what position is, right? Otherwise, we'll say, if it's a wall, then we'll say set bit, wall 0, an absolute position, set it to 1, and that's walls 1. Or, yeah, then we actually got to recurse, parse walls more, next position is absolute position plus 1. Okay, and then of course we got like we also need to have a rule for if it's not equal to that. Char is not pound sign, then we're gonna just recurse, and walls on either side of this relation is the same because we're not changing anything. So that should be parse walls, right? So let's try parsing some walls. Okay, so why the heck doesn't that work, huh? Okay, so we're here, right? Oops. And let's see, over there. 0. Okay, so we're doing something, it's just not finishing. It's not. Okay, next position. And so we're getting here. Yeah. Parse walls more. Right. Well, now I'm hella confused. Oh. You know what? We're not dealing with new lines, though. I forgot about that. I guess that shouldn't matter, though, because no, yeah. If it's a new line, we don't want to increment absolute position, but what does that have to do with anything? I mean, this should still work. It should just give us the wrong numbers, right? So parse walls more. Next position. And you think you get here. Next position, and you ignore it, and then walls 1 just unifies with walls, spits it out, right? So what the heck? Okay, I think at this point I gotta trace, and then we'll see where it's failing. Wait. Set bit. Set bit. Okay, so it seems like it's setting the bits okay. Parse walls. What the heck? I think okay. Let's back up a bit. Parse walls. And we'll just give it something with like 1 character, okay? So okay, so that works, right? And so what happens if we got like 2 characters? Okay, so that totally works, right? So So, okay, so it's getting snippy when I'm putting new lines in there. But why? Okay. Oops. Uh-oh. How the heck do I get out of here? Okay, so it's getting all the way here. Blah, blah, blah. Then it's getting to the second line. Oh, no, it's getting all the way to here, and then it's failing when there's a new line. We gotta think about why that's the case. So let's try to simulate that situation. Okay, so that... What? Oh, okay, so... What kind of weirdness is happening here? Well, let's try writing that rule that we said we're going to write anyway. For a new line, it's pretty easy. We don't need the increment absolute position, so parse walls when the first character of the list that we're parsing is a new line is the same as parsing it if that new line, just parsing the rest of the list, right? So still doesn't work, right? Man, what's going on here? More. Am I tripping? We did say, okay. Input. What is this? Like the, let's see. 1, 2, 3, 4, 5, 6, 7, 8. So like the 8th character should be the new line character, right? Alright, okay. Yeah, okay. Okay, let's think about this. So, shouldn't be matching here either, for that matter. Well, that's weird. Oh. Okay, so I literally said... I must be doing something really dumb. I just can't figure out what it is, you know. I'm sure I'm going to figure out what it is like in 2 seconds. Wall 0. Wall 1. More. More. Yeah, so... So like that clearly works, right? Okay. At this point, I'm going to back up and then let's get rid of these special rules again, and we'll just have 2 rules. Yeah, okay, cool. So that works. So what did I do wrong? Maybe it doesn't like matching the pattern, matching the character right in the... Something's wrong with this rule, right? Maybe set bit's not working right. Position. Small 0. Small. Yeah, okay, so I think maybe we do have a problem with like set bit or something, huh? So let's just like try to set every bit. Regardless of what character it is, right? Yeah, okay, so that works. So, that's weird. Okay. You know what? I don't have time for this. I'll just say. Okay, so I'm gonna set it if it's like, if it's a pound sign. Okay, and then we also gotta ignore the new lines. So I guess that's probably fine. 15. Yeah, Okay. It's terrible and I hate this, but this will have to do for now. Okay, there's our wall parsing code. Let's just copy this twice for the package positions, and the player position will actually be a little bit easier to implement because we'll just need to look for one value instead of a list of values, or a bit set of values. Parse packages, that's cool, and then player position. So I guess I really can't pattern match on a character these days. I didn't realize that, but maybe that's the case. So player position, I guess, is fail. If you can't find it, right? Oh, let's see. What the heck? I must have done something wrong. It's not jumping to the right place when I try to do a new line, which is telling me something's busted. But don't know what. What? If I'm manually indenting it, you know, we're in trouble. So, oh, there we go. Now it's working. Is it? Okay, let's try saving the file again. Save. Nope, no, it's not now. Okay, anyways, position. So if character is, what do we say character is for the player? Then true. We're done. We found the right position. Otherwise, okay, so I think, let's see if that works. What? Oh, I guess we need like a start. Right, hold on. Position. Well, it doesn't have any value yet, so start position. So we gotta start with 0, right? Okay. We'll make it like a three arity relation instead. Oh. Yeah, okay, so it's that position 20, and then we should be able to say, well, that's like the absolute position, right? So we should be able to use the absolute position relationship to kind of run it in the reverse. And how wide is this thing? I think we said 8, right? So we'll just go with 8. We'll say absolute position. Yeah, okay, so interesting. Oh, we gotta put these in domains. Okay, x is in 0 to width minus 1. And then y is, I don't know if y needs to be put in a domain because we should be able to figure it out based on whatever the other input is. I guess we could say it's greater than or equal to 0 though. Yeah, okay, so player is at 2, 4, and x, y, so 1, 2, okay, no, x, y, so x is 0, 1, 2, and then for y, 0, 1, 2, is that the one I used? Oh, hold on, we got the board right here. 0, 1, 2, then 0, 1, 2. So that's like 2, 2. Why am I getting 2, 4? Oh, what the heck? Is this the right width? 0? Okay. Man, my absolute position magic's already messed up. 4, 2. Maybe we're going from the wrong side of things. 0, 1, 2, 3, 4. Oh, jeez. Why is my life like this, huh? Think about this. How is that? Absolute position is 20, so it's like the 20th character, right? So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, we're not ignoring stupid new lines, are we? Okay, that's what our problem is. Okay, I think that looks good. I hope I didn't mess that up. But we'll see soon enough. Okay, so I think we can have our walls and our packages and our position now. So at this point, I think we should try to like print the board and see if it actually works or not. So we'll write a little function to print the board, and then if that all works, then all we got to do is write the code to iterate through the board, and then we got like the coordinate stuff half working, and then we're like pretty much done. This is the hard part right here. But I think we've got the tricky stuff figured out. It's all because I wanted to do tricky data structures, right? You know, I could have done this the easy way with list of lists, you know, but then I guarantee you we'd be going back and doing this in the end anyway to make it perform in a performant manner. So let's say print room. what is this? Is the room, print room. So we gotta know width and height. Right, width and height. Or should that be like a pair? It should be a pair of x and y, but height is the width is the max x, and height is the max y. I guess that makes sense for now. With height, okay, and then we gotta know the what do we say? We gotta know the walls. And for the millionth time, it's not player position; it's a robot position, right? Walls, packages. Okay, so I think we'll do it like this. Write a little relation. Okay, I think my like indentation's messed up because it gets really tripped up when I write like a character literal. So I'm gonna just dump all this stuff at the bottom of the screen because it seems to work fine for things before these, right? So let's try this out. Yeah, there we go. Now it's working again. So position is XY. So X is in, okay, max X is width minus 1. Max Y is height minus 1. X is in the domain of 0 to max X, and Y is in 0, max Y. Okay, so this will actually be, this is like a generator, and that'll generate all the positions for width and height. So I think this example is 8 by 8, right? So, oh, we gotta tell it. We gotta say, please, at this point, right now it's actually just spitting out one set of logic variables with constraints on them, but I will say find all the concrete values for X and Y. So now I should say, yeah. But we actually want to do that in the opposite order. Say find all the things for X, then you can iterate Y, or increment Y. Yeah, okay, so that's giving us all the pairs, right? That's cool. X is 2, Y is 1, X is 3, Y is 1. Yeah, I think we want to do it that way because we're going to want to print all the values for 1Y, and then, yeah, okay. So we'll do it like this now. So to print a board, we'll say for each position, find all positions, and then for each position, print position. Yeah, okay. Okay, so absolute position. Okay, so we'll get all the absolute positions, and we'll say and then we'll just, so I guess we should do like, what should we do? I guess we'll do find all. Or map list, maybe find all. Map list. For each, I think we want to do actually here, for each. Let me make sure I did this right. Did I do? I think I gotta do it like this. But we'll see in a second. All right, we'll find out soon enough if I did that right. Okay, so now we're gonna say, let's figure out, do we know if our wall's at position? Let's see. Oh, we could just say bit get bit. Yeah, okay. So that's a relation such that a wall is at that position, you know? So if that succeeds, then there is a wall there. So we'll say wall at position. If there's a wall there, then we're going to print a wall, okay? If there's not, let's say package at position. This is totally a pointless relation, isn't it, you know? Why are we, this is like literally the same thing, right? So let's just say bit. In the interest of making this code clear, I'm going to do it like this. Okay. Right. I'm just going to print everything in one giant line though, right? So, okay, let's see how badly we mess this up, or maybe it actually works. Okay, so parse input, input, and then we'll say parse walls. Input. So that still works, right? Cool. Parse packages. There's no packages. Oh, dear Lord. Oh, it's not a 0. That's why it's an O. We got our giant number, and then robot position. Input is a, yep. Yeah, okay, cool. I think that's all good. We'll call that parse input. So I don't have to type that all out again. Oh my god, my indentation's messed up. Okay, so now I should be able to parse input. Right. Yeah, that looks good to me. Okay, and now let's see if we can print that input. Print room. Why is this not syntax highlighted? No, okay, it is now. Okay. And what do we say? 8 by 8 walls. And this should all print on one line because I didn't put any new line code in there. And actually, to flush everything we printed so far, we're gonna have to tell it to print a new line, I think. So, didn't like that. Get bit. Okay, get bit. Oh, this is not get bit 1. Why isn't it printing anything? It only printed one thing for each position. I did for each wrong. We gotta look up how to do for each. Oh, did I have the browser window up the whole time? Why didn't you guys say anything? Oops. For each. True and I don't think this is what I want actually. Okay. Never mind. We'll do this. We'll do maplet. Find all. I think find all should work here. I'm gonna move this up because you know we're doing character literals and we broke stuff again. So find all. So we'll find all the absolute positions, and then we'll just and then we'll just map lists. Just have it. Yeah, should that do it? Okay. Oh. Absolute position. We'll do it like this. It's trying to pass in each value of an absolute positions as one extra argument. So we'll do call preposition. We'll partially bind it like so, and then it's supposed to be printing something, right? Where the heck's my printing happening? What? Seemed like it printed something. Right. We've got to make sure these have concrete values, right? Otherwise it's doing like complete nonsense, so. There we go. So it seemed like we printed everything. Got all absolute positions. Printed them. Why is it printing it like that? I didn't want it to print with quotes around it though. Okay. How do I? There's some way, like, must be some way to print like one character, right? Print character. Okay. Wait. Print character out. Oh dear lord. Okay. So I think I gotta tell it like what output stream to print to. Let's try. Print character. Current output stream. No. Oh geez, this is not even what I want, right? Unknown procedure. Why is autocomplete? Oh, man. Okay, this is when we gotta look this part up now, huh? So, print. Print a term. Portray. Right term. Right. Oh, maybe I want right. I think that's what I meant to put in the first place. Did I put print? I must be a clown. Hey. Dude. My bird's trying to attack my computer mouse. Dude, cut it out. Okay. Where the heck were we? Yeah, okay, cool. That looks nice. Except we just got to put the new lines in there, right? So, wait a minute. Does it look nice? No, because we only got the player position. Right. I think we got to put all this stuff in parentheses, right? we got to group these together. I'll be honest, I don't 100% understand how how I'm supposed to do the parentheses in situations like this, because I feel like I've seen code that looks like this, but it seems like it gets tripped up sometimes, you know, so. What in the world's happening now? Okay. This is not the indentation I was expecting. What the heck? This should be 1, 2, 3, 4. What the heck is going on? Oh. What? No. Right. Yeah, okay, okay. Otherwise, yeah, okay, let's see if that did it. Nope, you know what? That wasn't my problem at all. Okay, so let's back up. It looked way nicer when it looked like that anyway, right? So let's see. Okay, so this was like kind of working, except for it was only working for the player position. So row position, object at position maybe is not doing what we expected it to. Get bit. So what do we say objects is, right? So input or walls is this, and you know there should be a wall at 0, 0, right? And the absolute position is 0 is 0, right? So here's our walls, right? Okay. Did we do get bit? No, get bit. Bit is what? Okay. Oh, object at position. Are you trying to play me? Get bit. Huh. Okay. This is just proof I don't know what the heck's going on. Because I don't understand why it works when you do it one way but not the other way around. But I'm not going to waste my time trying to figure that out right now. Okay, so it looks like we're printing everything. Now we just got to make the new line stuff work. And I guess we got to pass width in here. And we'll say... Yep. Actually, we could do that inside print room. No. Print position for each absolute position. Yeah, okay. We'll do it like this actually. We'll make another arity. And we'll have that like just hand off to the other arity. And then if width mod absolute position mod width -1 is 0, then we are going to new line. Otherwise, nothing. Let's try that out. Well, that didn't work. That did it. Oh, wait, what? Oh, we're not calling. You know, that function could be the best function in the world, and if we don't actually call it, it's not going to work. Yeah, okay, so. Yeah. Huh. Totally cool, but I don't think I needed to subtract the 1. Oh. Great. Okay. Uh-oh. So it's, what's happening here? So it's doing a new line. I think we got to print the new line first. Yeah, okay. There we go. This does look exactly like the original input. Cool. So that's all done. We figured that out. Figured out how to parse the trash into our giant numbers, do bit shifting magic, which should make this actually like reasonably performant. Next step is, now that we've done all of that, we have to actually implement the move code. So I think this should be like pretty straightforward. So move packages direction. I'm gonna make direction the first argument for move. And I think right now, oh my god, I left my browser open again. Just hiding half the screen. You guys can't see what I'm doing. You guys gotta say something. Sorry about that. Okay, so, but in this case, I do want to open because I want to look at the input. So, yeah, so we got these are the 4 directions, right? So move a direction. So yeah, we got this initial state, and let's see if it looks like that after moving it left. So let's try to just get that stuff working. Okay, so what are our 4 directions left? Right, I think we could just use the characters right now. Let's try this. Let's just do like a really simple placeholder. But if I use, you know what, I don't want to use the character codes because it's gonna screw up my editor. I don't know what it is with this Prolog mode and Emacs, but you know, if you type a character literal, then like I was saying earlier, all of the indentation and the rest of the file's messed up, you know, which is why I put everything down here instead of, I would have been writing at the bottom, you know, but I don't want to mess everything up. So let's say we'll move left. We'll figure out how to translate from the character codes to like these actual atoms like left in a second, but that's not like super hard. So left. Okay. And I'm just gonna define a little dummy relation right now to start working on stuff. Okay, and then okay, so this isn't actually doing anything right now, so let's try this out. Yep. Well, where are we printing? Yeah, we don't want to print that out. Why is it only printing it once? Print room. Oh, oops. I said X. There we go. So yeah, okay. So we're printing it, we're moving everything, and now what happens if I try to move right? It should fail and not even print the second time, because that's not a direction you can move in right now, right? Okay, cool. So next position is, okay. We need a relation to find the position to the left and to the right and what's and what not. So we'll call that next position. P1, P0, P1 position. Let's call it, I like to lean on the side of longer names just because, you know, what do they say? Code is write once, read many. And so when I go back, I'm like, oh, what does P stand for? Is P for parrot? No, that's what's on my shoulder, right? P is for position here. So position 0 is like kind of the input and P1's the output. Or I guess the right way to think about this in Prolog is position 1. This is the relation such that position 1 is the next position of, if left of position 0. If you were to move left from position 0, you get position 1, right? I guess. Okay, so, well, that's easy, right? It's just position 1. Right? Because the absolute position, yeah, but, well, I guess That doesn't make a ton of sense, because if you try to move all the way to the left side of the room, then it doesn't care, and it would just flip you over to the right side of the row above you. But that doesn't matter, because everything has walls on the edge, right? Or that's what we assume, right? So, I mean, I guess we could look at our input and see if that assumption's okay or not. Yeah, we have walls all over the edge, and we're not moving from the edges then, I guess. So that's probably actually fine. Do we want to do it the, like, wacky way? Or you know what? For moving up and down, we got to actually kind of translate it to a real XY anyway. So let's think about how to move up and down, and then we'll decide if we did the way we did left is too hacky or not. So up. We got to know width for this stuff, so we'll call it X. We're only moving Y, so X. So X will be the same on both sides of the equation. And Y1 is Y0 minus 1, because you're moving up, you're decreasing Y, right? So, oh, wait a minute. Right. Okay. We gotta get the absolute position, right? X, Y0. And then absolute position. Y1 is Y0 plus 1 minus 1. Okay, so next position, let's try this out. Width is 8. If we're at, like, I don't know, let's say we're at 0. How about, let's say we're at like 12, okay? Next pause is Shein. I just spelled that right? Yeah, next is 4, okay? Yeah, that's easy enough. I guess actually we don't need to do all that math. We could just say it's position 1 minus width, right? Am I gonna regret this, or is this fine? I guess the only thing that I could see being bad there would be, you know, if we like ran off the board or something, but well, I mean, we could always say position 1 is greater than or equal to 0, if that would make me feel better. But I think realistically, if I code this up right, we don't have to worry about running off the board, because we're going to run into a wall, and the code just say, hey, we ran into a wall, no more doing anything. So I guess maybe this is fine for now. Maybe we don't need to overthink it. So I'm going to make these all have the same shape, and then we can say, so we'll have down, and that's just plus, and then, okay, and I like to make everything look pretty, so let's align those like that. Actually, let's align them back here. Now it's very easy to read, you know, because it looks kind of, it's like reading like an Excel spreadsheet or something, you know. It's beautiful, beautiful to look at, you know. There we go. Now we get our next position, right? So let's say move robot. Okay, so what is the relation to move a robot? Left, okay, so next, so let's see, next position, potential next position, I guess you'd say. And if there's a wall at the position, we're done, right? So let's say wall at, man, where did I swear to God I wrote this earlier, didn't I? Object at position, yeah. Why are you doing that? at position wall. What's the absolute robot position? 1 walls. So let's see, if there's a wall there, then we're done. So we'll do it like this. True, because we don't want it to backtrack. So we'll say if we're here, we're done. No more doing anything. We didn't do, actually, no. Robot position. Okay, so we're just gonna say the final robot position, final packages value is, the same as it was before, if there is a wall there. Okay, if there's no wall there, then we've got to say robot position, robot moves there. Yeah, okay. Robot position equals position 1. I'm trying to think, do we even need to have like kind of this intermediate value of robot position? I don't think we do actually. Robot position 1. No, we do, because that can be different from the final output. Okay. So we'll move the robot there, and then we'll move the package there. We'll say move. I'll say move. What the heck? I can't type the right package. Left walls. We don't need the robot position to move a package, right? Which is okay. I think that should do the trick. We'll move the package left. And if that doesn't work though, then we'll have to backtrack and do the same thing we did right here. But we'll come to that in a second. Backtrack. Do this, or how can we code? Oh, I know what we could do. Okay. I think we could code this up like as one big fat rule. So we'll say not. The object position is not a wall, in which case we can move the robot forward and move the package forward and so forth. And that would be cool, we're done. Or we got to backtrack. Impossible. Don't do any moves. Okay. So now let's try to move packages. So let's write this relation. And that's actually width left. So that'll be our relation for moving. I guess to move a package, we gotta know width as well. So because we're gonna need it to get the next position. So as you can see, left doesn't need to be left here. It can just be a parameter. So bam. That shouldn't do that. Okay, and I think we actually, for the same thing, we don't need a special version to move a package left versus like moving it right or whatever, So move a package. So okay, so we'll say move the package. So set bit packages 0 at, wait a minute, where the heck is our position? Oh, next position, package position. Okay, let's think about this. Where are we moving a package? Robot position, and then move package at robot position. What? Let's say. Okay, move package at okay, so base case, there's no package at package position, right? Then we're done. So position okay, so if there's there's not a package to move, we are done. And then the output is the same as the input for packages. Cool. On the other hand, if there is a wall at that position that we're trying to move the package to. Oh, a wall at the next position. Yeah. Next position object. Yeah, okay, because this is never going to be wall. The package position, package position should never be wall because we're checking to make sure it's not a wall. We're only calling move package if it's like not a wall, right? So, okay. So, there's no package there, then we're done. Don't need to change packages. Otherwise, I guess we can assume there is a package there because we know it's not a wall and we know it's not the robot. So in this case, we got to figure out what the next position is. So we'll say next position. Okay, now we know the next position and we say object at if the object at the next position is a wall, then we fail. And we can actually just write, I think we could do it like this. So for this rule to succeed, there cannot be a wall at the next position. And then I guess we just recursively move if there's a package at the next position. And if there's not, then we'll hit this case. So with direction. We gotta actually move the package in the first place before we recurse. So set bit packages 0 package position to 0 because it's not there anymore. Okay, and then we gotta actually say packages 1 next position we gotta set to 1 because the package we are putting a package there, and we'll call that packages 2. But actually, well then this is just always gonna record. Okay, I think what we gotta do, move this package into like the ether, recursively move the next package, and then go back and put this package in that slot that opened up, if that's possible. So we got packages 1, packages 2, and then we'll set the bit in packages 2, and that will be the output packages. Yeah. Huh, does that make sense? I think it makes sense. So there we go. That should be how you move a robot. We need height to print a room. I guess we do, yeah, for position. Okay. So let's see if this works. What the heck? Why did nothing just happen after all that? Okay, let's Okay. So let's add some logging in here to figure out like what the heck's happening. Oops. Oops. Learn to type cam. And we'll see, are we even moving a package or not? Right, next position. So why the heck did we not move a package? So. Oh, we can't move left because there's a wall there. So maybe this is working right. Okay. Maybe we're tripping for no reason, huh? Let's see what happens when we move up. What the heck? Yeah, okay, up. That looks good. What happens if we move up? And then move right. Will it move my packages? Oh my god. Yeah, okay. So I think at this point, we got to write something better because I'm just copying this over and over again is getting ridiculous. So let's write a version of move that can recursively move a bunch of moves. We'll just call it move. What's a good name for this? Let's call it move. It's like the higher level one that we're actually going to use at the end of the day. So we'll do it like this. If directions is empty, here's our base case. Then both sides, the input and the output, unify. The input is the important parts, the things that change, the packages, robot position, and then the output is packages and robot position, but it's the same when there's no more moves to do. That's our recursive base case. So so we'll do, to move once, we'll just do move robot with direction, walls, packages 0, robot position 0, packages 1, robot position 1, and then we'll recursively move a lot more. Okay, that should do it. So let's try this out. And then let's have it print. I'm just going to stick print in here so we can do it every time just for right now. With height. Yeah. Robot position 0. That way I don't need to like worry about having to print a million times. So now let's up. What do we want to say? Up. Right. Yeah. Okay. Uh-oh, didn't like that. Oh. Size. Directions. Walls, packages. Position, more packages, another position. Yeah, print, room, move, robot. It's not even printing the room. So, which would mean it's not even getting here, right? Oh, oops. Okay. Yeah, okay. Direction up, direction right. I think when we print the room, we got to print a new line at the very end. Yeah. Okay. So we move up. Well, yeah, that's not confusing at all, right? So we move up from here. And then we're going to move right from there. We better just print that board one last time, huh? Print room, move robot. I think it's probably better to print direction after we print the room instead of before to make it like less super confusing. Oh my god. Okay, then we move up. Then we got that. Then we move right. Yeah, okay, cool. Okay. Let's just do this. And then we'll move right again and see what happens. Right. And then let's try moving right one more time and see if it like moves our stuff the way we want. Yeah, look at that. It moved our packages. And what happens if we have to move right one more time? Nice. It doesn't. Okay, so what's happening is it's trying to move, right? Trying to move the robot. Trying to do all this stuff. But then it is failing here. This rule fails. And so it's hitting the kind of else branch. And then just saying, well, don't do anything. No op. Output packages and output position are the same as the input. So there we go. So we only move if we can like kind of move everything else that needs to get moved, you know, until there's no more moving to do. So I think all our moving code looks good to me. So I think at this point, the only missing piece is to do all the GPS coordinates now. So that's all up here. I think since we're going with these absolute positions though, we should just try to stick with that for doing the GPS coordinates. So let's get my X that I'm using to test stuff. And we'll move this to the top. I would normally do this at the bottom of the file, but like I was saying, my character positions or character literals for whatever reason are like destroying my editor. So I gotta type all my new stuff above all these definitions below that have character literals in them. So we'll do it up here. I think X. It doesn't really matter what order you put stuff in the Prolog file, I guess. You know, as long as you, I guess the important thing is like rules with the same arity have to be grouped together, unless you set a flag that is not supported by all versions of Prolog called discontiguous, which means you could put like I got this version of next position 4, and then I gotta have like another one somewhere else. But I guess, you know, just for the sake of keeping everything organized, I'm gonna keep them grouped together anyway. So coordinate. Okay. So what do we say? GPS coordinate. Package GPS. We'll call it. It's not a BOC. It's a package, right? So position. So our relation will be such that absolute position with okay, and then packages. So we just got to check every bit and then see if there's a package there. Is there? I think there's like a, well, there's definitely like a population count to get the number of bits that are set, but maybe we just got to flip through every bit. Okay, okay. I don't think this is too hard to do. Position. So position, okay, so we'll do it like this. All positions, we'll call that set bits. How about set bits? Set bit indices. There might already be something like this, so let's go look at the docs. Let's see, set bit bit operation bit or bit XOR. Oh, there's a bit XOR. Oh, we already used that earlier, didn't we? Bit hand. bit is set at index does not maybe exist, but we can write that. Okay. Bit is set at index. So we already kind of wrote something like that, right? Like, hey. Okay, so we'll do it like this. There's no more bits set at any more positions if it's 0, right? We know that much, right? So set bits, where do we say? Set bits. We'll call it set bits. Is that? Otherwise, that's our recursive base case, okay? Set bits in bits is, so in bit and is, man, the wacky syntax. Bit and 1. Next bits equals, what's our current position? Let's think about this. I think we gotta have we got a bit shift. And then when yeah, I think we got a bit shift is right though, right? So, okay, in is like 100, okay, and then next in, oh wait, what do we know? Like 12. I wish I had a way to just type like binary literals, you know, like you do in like whatever other language, 0b, 011, whatever. Oh my god, what if I could? Can I do that? Ha, that whole time I could do that. Wow, I'm a clown. Okay. So let's say this, and then we'll say next in is in bit shift left 1, bit shift right 1. Okay, so next in is 3, 0. There's probably even a way to print it that way. I just don't know what the heck it is. Next in is B. Yeah, that's right. Okay, so yeah, so we're gonna see if the last bit is set by bit anding with 1, okay, and if it is, then the output's gonna include position, and then we'll bit shift right, and then look for the next one, and well, I guess we gotta do that either way, regardless whether in is set. So we'll do it like this. In bitwise and 1, then bits is, otherwise bits is just, I don't know, more bits. And then recurse. Yeah, okay. It's complaining about this, but I don't know why. So let's see does this work? Uh-oh, it didn't work. Okay, so set bits. Yeah, okay, so the recursive base case works. Let's say, does that work? No, okay, why not? And why does it not work? Okay. Let's try this out. Let's kind of step through this. Or we'll use the debugger. Trace, no. Step through. What the heck? Oh. Oops. It takes 3 arguments now. That's why it doesn't work. Okay. Position starts at 0. I think we gotta put like this has to be an equation. But we don't want to fall into the trap. We gotta say 1 is bit. Okay. That seemed to be recursing forever now. More bits. Why the heck is that? Abort. Okay. Next in. Okay, oops. In is greater than 0. So this is terminating, but then it's also, here's an alternative way to satisfy that query you're just asking for. You know, so it's gonna basically recurse forever unless I tell it this rule only matches when n is greater than 0. So no, that should do the trick. Okay. Yeah, okay. So we got 0th bit, the 2nd bit, 3rd, 4th, 9th, 10th. Okay, so we got all the positions that are set. Okay, cool. I guess the only other thing that we need now is the GPS coordinates for an absolute position. Oh, we already got that. So I'm gonna move a bunch of times, and then we just gotta get the GPS coordinates for each package, you know, so. Let's add a to arity for this. That'll set position, which always starts at 0. For the sake of usability, set bits, packages 1. And then we could do map list to get the GPS coordinates, right? So absolute position, yeah, okay. So we're gonna partially bind package GPS coordinates, and then we'll use the version of map list that calls it with 2 arguments. The first argument is the input, and the second argument is like the output, right? So we're just gonna do map list, and we'll do all the package positions, and then we'll get all the coordinates. Robot position 1. I guess robot position 1 ultimately doesn't matter. Okay. So we'll say, yeah, okay. So let's print out, let's return. Okay, let's try X. We don't need to print all this stuff anymore. Okay, so let's look at the prompt again. So blah blah blah. Okay, we didn't actually take like the actual like input, right? To see if we did this correctly. So let's do that. So let's do directions equals. Okay, now at this point, do I just want to rewrite the, yeah, okay. New plan. So because I said double quotes is actually like a list of characters. So if I type in double quotes, it's actually just giving me a list of characters. So I don't think we want like left, right, down, whatever. I think at this point, the only reason I didn't do it like this in the first place is just because it's like messing up my editor. But I think at this point, as long as we don't put more code below this, it'll be fine. There we go. Now all our pretty indentation's all messed up. Okay. So let's try this, see if that works. Oh, jeez, what the heck? Okay, so that's our output. And it says blah 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 blah. Finished. It should look like that. Is not what mine looks like at all. Oh, the larger example. Yeah, what example was I doing? Uh-oh. I think we did the wrong example. Here's a small, oh dear lord. Well, let's work on the small example for now. Blah, 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 blah. Okay, well that doesn't give me the exact, it looks like I'm like moving it right, but let's take the larger example so we can actually see if our code works the right way or not. So I'm going to copy that. Okay. And we'll copy this gigantic list of directions. Uh-oh. This is getting silly at this point, having this gigantic string just hard-coded into my file. But I guess it's okay for now. Okay, so like let's see what happens, you know. Okay, so let's see. Did we actually do this right? Blah blah blah. Looking at the large example, it should look like this at the end. Mine does not look like that at all. I totally broke the heck out of it. Up. All my walls. Oh. It's the 3, 4, 5, 6, 7, 8, 9, 10. Okay, you know what? Bad idea to just hard code width and height because it's, you know, totally wrong already. So I think these are all like squares, right? So input strings, yeah. Let's make parse input actually return like size, width, height. That's that's the secret sauce here. Actually, we could do it like this, size. Parse input should return size. So we'll say input. It's just a bunch of lines. Parse one. Okay. These are all the lines at this point. So I'm going to change this to... Actually, I guess it's just a stream of characters, right? We're not splitting it by lines, right? So, okay. So here's how we'll calculate width. We'll say, oh my god, my bird's stepping on my keyboard. So here's how we'll calculate width. If character equals new line, then width equals 0. Okay. Otherwise, width more width. Yeah, so I think it'd be better, you know, this is like the simple way to do it. It'll just keep kind of looping through until we find a new line, at which point that'll be the width, right? So we'll say input, width, input, should give us like 10, right? That's good. And is it like a good idea to assume these are square? I think in practice, these are like I think most of these are squares, right? Is that a square? Man, it's hard to tell if anything's a square these days, 2024. I guess we could just look at the length input and divide it by width, huh? Height. Didn't like that. Oops. Yeah, so I guess this is a square at least. Okay, so I would say this. This is not the most efficient way to write width because it can't tail optimize when it recurses here because it has to kind of push a new kind of relation on the stack each time it recurses. I mean, if you wanted to do it, you do it like it the way I wrote most of the other ones. Like would be like the good way to do it, I guess. You know, next width is yeah, you could do it like this. This would be, I guess, the better way to do it with. Yeah, so we're with 0 and this is just kind of serving like an accumulator, serving as an accumulator. And then now every time we iterate, we can kind of completely just, it can iterate with, it can tail recursively optimize this relation, and it doesn't need to keep new things on the stack every time, right? So much more efficient. Now, it really doesn't matter for something that's 10 characters long, but if I'm going to try to do things like the nice way, I might as well do it the nice way in the first place, right? So we'll say input, and we'll make a 2-arity version anyway, so when you're using it, it doesn't matter. Because 0 is like the initial value of the accumulator, right? So there we go. So that's size, input, and we'll say with input the height. Okay, so now parsing the input should give us width and height, right? Cool, right? So now, oh, there we go. Okay, so let's look at our prompt again now and see how far we got. See if it looks right. Oh, that looks pretty good to me, actually. Look at that. Almost exactly right, except for heck. How the heck did that happen? Oh, I don't think we're printing the last state of the board, are we? Yeah, that's just for the sake of making sure we're not on drugs. Let's print that last board. So print board. What is that called? Print board. Print something. Yeah, I can't remember. Print. They call it print room. Okay. Print room. Where? Here we go. Print room. Now I do need size. Okay, so let's try this again. There we go. So we got our final room. Yeah. That looks pretty good. Okay, and then so our coordinates are. Yeah, I think I did that right. The sum. Yeah. Oh, they did have a sum for the smaller examples. So I need to waste all my time with this. So now let's see if we could sum these up. So we could sum the list, or we could just calculate the sum in place and not even have an intermediate list. You could do that like this. So we got to take all these coordinates and just add them all together. But we could do aggregate all sum sum of coordinate map list. Yeah, package positions. Package positions. Where did package positions hit bits? Okay. We do want to do map list coordinates. Okay, so there's like two ways to do this. I can have coordinates and leave it as like an intermediate list, and then just do fold and fold them all, which I guess is like probably fine for now. It would be faster to not even have the intermediate list and just sum them up as we go. But then if I want to go down that rabbit hole, why am I even making this return a list? You know, I could just have this like return multiple solutions, and then I could have aggregate all could just kind of get every solution and jam them together. But that, I think at that point we're just making this unnecessarily difficult on ourselves. So we'll just do fold list, and we'll say yeah, at this point I want to use like a anonymous function like a lambda, and I guess there's like not a standard way to do that in Prolog. There's different libraries that have different syntaxes for that. So I've been using y'all, yet another lambda library. So let me import that so it doesn't get tripped up. It does like some kind of operator overloading magic to make it stuff work here. So fold takes a function or a relation with 3 arguments, which is like, I guess in this case it'd be each individual item in the list, or we'll say like coordinates, because we're going to pass the list coordinates, and then initial value of the accumulator and like output value of the accumulator. So we'll say and then we need the initial value, and then the output will be out, and this will be our relation. Okay, so let's call x. Bam, out is 0. That's totally wrong. That's the wrongest thing in the world. Coordinates. There we go. 10. Oh, look at that. There we go. 10,092. And what did I get? 10,092. So I think at this point my code works. I'm pretty confident we're good now. We do have to write the code to actually read this from a file, so let's go ahead and do that next. Okay, so I'm going to take this example input and stick it in a file, and then make sure it still works. Making sure we're reading the file correctly. So we'll call that day 15 example.txt. Okay, and to write this from a file, read this from a file, think about how to do this. Okay. I wrote some utilities because these are all literally like the exact same thing. You know, read stuff from a file, and I don't want to have to figure out how to do that for like 800 times, you know, so I think we just want to read the entire file to a bunch of characters though. Read. We don't want to read it line by line for once in our lives though. We want to read it to, basically we want to read all of the first part, and then when we see 2 new lines in a row, then we'll read it all as the second part. So I'm going to read the characters, read stream, read file, lines to characters. Yeah. Okay. Read line to read. How does read line to string work? Okay, I think we're going to start with this, but we're not going to split it up by lines. So I'm going to stick this code. This code is all like super disorganized because it's not in any sort of order anymore. It's like making me sad, but like I said, it's going to break up. It's going to ruin my indentation if I have my character literals above. It's going to ruin the indentation and everything else. So I'm just going to stick this above everything else for now. Let's see. Read file. We'll call it parse file path. And then what happens when we parse something? You get all this crap. And you also get moves for that matter. So this is the relation we want to write. Okay, so we have our stream, and then read line to string to codes. Yeah, there's no read line to characters, unfortunately. So we're gonna have to read the line to a string. Read this line by line. Can I read the entire stream somehow? Read. Read what? Read stream. Can I keep reading until it's empty? Is there a read? There's no read character. Okay, so we'll do this. We'll read it. Okay. New plan. Read file. Path. Lines. Let's just try that. Ooh, didn't like that. What are you talking about? That file exists. I know that file exists, right? Read file. I think I did something wrong. Read file, last two strings, blah, 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 blah. Oh, we didn't have the base case. Characters. You know what? We're going to do this. We're just going to use the existing functionality I wrote to read the file to characters, and then we're just going to jam them all back together. I guess that we'll just have to do for now. Not a very efficient way to read stuff, but I don't have time. I don't think solving this problem is about having like optimized parsing code. Is it really? Parsing is not going to be the slow part about this. You know, it's doing all the moves, and I think our move code is going to be super fast because we did a bit set anyway. So who cares if parsing is like a little bit slower? I'm not doing this to have a contest to see how fast it is. If I was, I wouldn't be doing Prolog. So let's see. Let's do what the heck. So read file lines. Characters. Yep, okay. And then now, so we got all of our stuff, and there should be like a line in there somewhere that's like completely empty. So we'll do it like this. Read file lines to characters. Lines, and then we want to divide that into kind of like the room input and directions, which doesn't actually need any parsing. So this will be our relation that we're going to try to make work next. So split file read. How am I going to do this? Read. Parse lines. Or what is it? We'll call it lines. Okay, so we'll do this. So we're going to kind of decompose the problem a little bit now, and now that we're going to try to write this relation. So read lines, base case. No more lines to read. We are done. I guess this should probably be kind of like the same thing, like the input and the output. No, let's just write it like this for now. Okay, so we're done reading lines. There's no more directions to read, so that's done. And room input we'll assume has some kind of value, but whatever. Okay, so right. I don't think this is the way I want to do this at all. Okay, we'll say read line. Okay. Split lines, and then we'll read them. Oh yeah, okay, that's what I like. I think this is a better plan. Split file lines. lines, room, input, directions. Okay, so let's try to write this relationship, and then once we split them, then we could parse the room input or jam them all back together or whatever. Okay, so base case, split file lines, line, more. Are the directions? I guess the directions. 15 examples. Yeah, these have new lines in them too, actually. So directions input. Okay. We could do it like this. Okay, that's how we'll split it. Now, have your mind blown by that. We're basically saying the relation is such that lines is the same as if you appended room input lines, an empty line, and directions lines. So it's basically going to unify these two things together. And since the empty line is, where we want to split things, I think that should do the trick. So split. So let's just see how far we've gotten. Split. Lines, room, input, yeah, okay. File. That should be path. File. Apparently there's multiple ways to split this. What are you talking about? There's only one. Append the empty list. Oh, yeah, okay. I thought I was being super clever, but empty. Is there an empty list with? Wait a second. Wait, how are we supposed to? Okay. New plan. Read the file, do all the lines, and then we'll say map list, right line, lines. Let's just look at all our lines before we get ahead of ourselves. So yeah, there is an empty list. Oh, duh, that's what I did wrong. There is an empty list, but we're appending lists of lines, and the line itself is an empty list, so that has to be, okay. Okay. There we go. Yeah, okay, so there's only one way to split it. Cool, so we got all of our room lines. And unfortunately, we wrote all of our code assuming there would be it wouldn't already be split. So, we have all this code to deal with the splitting. And I don't want to rewrite that because we know it works. So we're going to do something really dumb that, hindsight, not a good way to do things. But we're just going to combine them all back together. So let's do string. Yeah, there's like no... Oh, interpolate string, yeah. I guess there's no kind of function to merge these all. Is there a split lines? Is there an unsplit lines? I guess there might actually. Oh, I could just run split lines backwards, I guess, right? Split lines. Right. Can we do this? Let's try. A, B. Right. Oh, there's no, what the heck are you talking about? No git split lines. I think I did this. Split reline is trying to split. Split. There's no split. I haven't done split yet. Okay. Fine. We'll have to write. We could do everything ourselves these days, huh? So, merge. This is like split string. Wasn't there a split string? Can I do split string backwards, right? Split string. Yeah. Okay. So I could do this, right? A, B, new line, C, D, and the separator is new line. No special padding characters, and then out. Oops. We said double quotes is a list of characters, didn't we? So let's use single quotes instead so it doesn't get all tripped up. It doesn't like that either. Oh, because that single quote. How? I think I gotta use backticks to write a string now. No. No. I think that's okay, actually. Yeah, I'm not super clear on how I'm supposed to write a string without using double quotes, and I've set double quotes to something else. So it's not like that. It's not. Doesn't like that. Does not like that at all. Oh. I think what I was doing was fine because it kind of knows what I meant, but I just typed my new line wrong. There we go. Yeah, okay, now can I run this back? I can run this backwards, right? And I could unsplit my string for me. No, why? Why can't you do that for me, huh? Okay, well, that would have been cool if it could, but it can't, so we'll just write unsplit string ourselves. And, I don't see any reason why it couldn't, make this. I guess, it doesn't know if there's padding character. Well, padding character is empty though, right? So it should be able to undo it, but it's not as smart as I would like. So we'll say strings, separator, out. Okay, this will be our unsplit string. Base case, recursive base case is out is just a blank string, right? Or right. But we're not actually merging strings anyways, right? We're merging lists of characters, so unsplit character list, unsplit characters. Okay, nothing to unsplit, then that's the output. Otherwise, out and L separator. Yeah, I think that should do it. More out. Pinned. More out. Separator. What? Out. More out. Wait a second. Wait a second here. So that's the out. Pinned. Oh. Right. Okay, so we'll recursively merge everything together, and then we'll jam that on the front, right? And, okay, more out. We could actually probably make this actually really recursive, right? So more out. L. No, maybe not. Okay. Let's try that. Let's bring it. That's almost what I wanted. Pinned separator. Separator should be a character and not a list of characters. And now we're good. Okay. Cool. So we unsplit our characters, read files, split file lines, and then immediately turn around and unsplit them. Yeah, definitely has to be a better way to do this, but I don't have time for that, I guess, you know. Call this room lines. So that will be how we read a file. Okay, so and we'll do one more thing. We'll say the example path is day 15 example.txt. Okay, so and then we'll make that an actual like real parameter in a second. Okay, so at this point I should be able to run X, I think. Again, how'd that work? X. Oh, okay, we didn't get that far, so path. Right. Yeah, okay, so we got a room input. Directions. Are we parsing it okay? I think sticking all these print lines in here is probably not the fastest way to do this. Let's just trace it instead and see where it fails. Right. Okay, we actually don't need to flip through the file reading code. Yep, I said we don't need to flip through the file reading code. So it's failing in parse input. Why is it failing in parse input? Parse input is failing. So let's do this. We'll move the trace over to here. Input. Okay. Yeah. It's trying to unify. We already got the input, but now it's trying to unify it with this rule that we don't want no more. So I think that. Okay. Okay, well, you know, we almost got there, but what? Oh, right. I bet I know what's happening. It's probably like a new line at the end of directions or something stupid. So let's have it just fail here. Yeah, comma, new line character. Okay. So what if we just didn't put the new lines in there and merged them all together like without new lines? What was the point of putting the new lines in there in the first place? I don't remember actually. Yeah, okay. So yeah, why don't we do append? Okay, append with the append to takes a list of lists and then give you a list that appends all those lists together, right? So yeah, that's almost good. Wait a minute. Yeah, hey, now it works. Woo. Okay, but I guess we don't even need to do the same thing for reading the rooms anymore. The whole unsplit is a bunch of nonsense, right? So let's say room lines, room input. Dumb way to do stuff. Okay. Well, it doesn't work anymore. Room input. Oh, you know why it doesn't work anymore? Because now we don't know how, we don't have width anymore. So, right. So what if we just had read file tell us the width of one of the lines though? Yeah, we could actually, I guess, have this thing spit out the size. Okay, so length of room lines is like the height, okay? And so first room line, I said, oh my god. What? Okay. Yeah, XY with height. Okay, so now read file is going to tell us the size instead of parse input. So don't need this anymore, I think, if we did it right. So read file, size. And then parse input does not need to figure that out. Parse input, parse input. Yeah, get rid of this code. And it doesn't even need size as a parameter for that matter. So parse input. Let's see how far we got with that. Yeah, that looks beautiful, right? Okay. And now we can actually take out this stupid code for dealing with new lines that just makes our lives like miserable, right? Because we don't need that anymore. So, and it should still work, right? All this ugly conditional code. Don't need width. We don't need this width relation anymore. Still works. Cool. Okay. We don't need to print the board every time, every iteration. It was only there for debugging purposes, right? So I'm just going to comment that out for now. Where's that format? Nope, don't need that. Oh, print board is what I call it. Print room. Guess we don't need to do that no more. Yep. Okay, so can we solve? Yes. I'm gonna call this solve now, but we're gonna change packages and coordinates is not interesting to us anymore at this point, but what is interesting is the input, like example. So we're gonna change it like this. It's gonna be X example out, and then out is 10,092. That's right. So I'm gonna stick this at the bottom where it belongs, you know, and then we're gonna move our parsing code in a place that like makes sense for once in our lives. Can live with its friends now. Parse input. Yeah, so I think this is pretty good for part one. The print room. Yeah, I don't love value at. Where is value at position even used? Right? Value. It's not used. Yeah, we don't use that. So yeah, okay. We only use this at the end when we're solving it, right? So move this down here. We're gonna call this solve. We should break this out into two parts. Parse and solve. How about input and solve? Input. And then oops. Okay. So does that still work? Uh-oh. Now it's called solve. Okay, so that looks good to me, and I think I'm generally happy where stuff lives now, kinda. Not using append 3 anymore. I think this code looks like mostly pretty good. Let's actually try to run it with the actual input now. Get your input. I already got that. Okay. Okay, so now the only other thing is like actual. Okay, moment of truth. Solve. Does it work? Oh, it works. Now, is this the right solution? Here we go. Cross your fingers, everyone. Let's see. Yay. Yay. How about that? Hey, man. How you doing? I'm doing good, man. How you doing? I am doing good. Oh, I can't chat from this window. Okay. Well, I'm doing good. Cool. Well, we got part 1 done. Let's look at part 2. I don't know if I feel like doing part 2. This took a really long time. I didn't think it was going to take this long. But I was like taking my time and explaining stuff and whatnot to the best of my understanding, because I'm like not a Prolog expert, you know. I've been writing Prolog for 2 weeks. I got to put that disclaimer out here. But I think I kind of wrapped my head around most of it, you know. But some of the stuff, like, there's probably some like library functions to do some of the stuff I did the hard way that I just don't know about, or stuff like that. So it's a little bit slower than if I had been writing it for like a longer time. And you only learn so much by writing like Havana code stuff anyway, right? So yeah, I think I'm gonna take a break at this point. So thanks everyone for tuning in, and maybe I'll do part 2 later. We'll see. But I'll catch you guys next time. So have a good rest of your day.